Hi, welcome to a2zknowledge.com. Today we are going to discuss about Spark standalone architecture. So Spark has various deployment modes. So Spark with Yarn, Spark with Mesos, and then Spark standalone. So when we say Spark standalone architecture, so Spark as a cluster, you are just installing only Spark as a cluster in single node or multi-node. So only you are installing Spark and you are doing all your activities, the jobs, everything only with Spark. So you're not using any Hadoop or any other technology integrated. So which means we call that as Spark standalone cluster. So even with Spark standalone cluster, you can build multi-node clusters, you can do distributed parallel processing, jobs execution, and all those things. But in real time, mostly we used to integrate with Hadoop. That we call that as Spark Yarn deployment mode. So in this video, I'm going to explain you the architecture of Spark standalone Spark standalone architecture. Once we submit the job, how the execution flow will be. So that's what we are going to discuss today. And Spark with Yarn deployment mode, I will make a video in my upcoming sessions. Okay, so let's get into the topic. So this will be completely an theoretical stuff. It we means not in this video. I'm not explaining. I'm not going to explain any practical stuff, but in my upcoming videos, I'll be doing it. Okay. So before getting into this, like few terminologies we need to know. So the very first thing when you install Spark as a cluster, when you start the daemons, when you start the Spark cluster, you will be getting some daemons. When you say daemons, when we say daemons, it's a background process which act as a backbone for the cluster. So with respect to Hadoop term, I can say like you have name node, data node, resource manager, node manager, secondary name node. Similar to that, when you start Spark, you have two daemons which is called master and then worker. So master is same like master what we say in Hadoop name node. So similar to that here, the daemon name itself a master, and worker is a slave node. Master means a master node, worker is a worker slave node. Spark comes under master slave architecture. So master and worker are the two daemons which you will be seeing when you give JPS command after installing and starting the Spark cluster. And the next one is the term that which we need to know is driver program. So what is driver program? Okay, so the program what you write. So in Spark, you write some program that could be word count program or whatever you write in Scala or Java or PySpark, whatever it is fine. So you write a program. So in which you will be having something called driver part where you will be declaring the Spark context. So Spark context is an entry point for your program which act as a main method in other programming languages like Java and Python and all. We have main method, right? So main method act as a starting point for the compiler to start the execution. So similar to that in Spark, we have Spark context. So or Hive context or whatever it is. So that area of code which you are doing, we call it as a driver program. And this driver program is the service which will be get started in the Spark master, and then the driver program will do all the activities of your job to task and all those stuff. So that is again I'm going to explain you. So driver program under which we will get the complete program, and the main part is Spark, the context. So which is the entry point for your compiler to start the complete execution. Okay. So now I'm a client, so I'm writing a program. I'm build a jar file, and then so I'm doing it from my client node. So client node is a node which will be connecting to the cluster. So now I'm sending an Spark submit request with my jar file. So this request goes to Spark master. So Spark master mission. Okay. So this in this Spark master, so there will be a process get started which is called driver program. So this driver program that will be get started for each and every job that you submit. So I'm submitting a job, so I will get one driver program. So similar to that, like there is one more job request is coming from a client, so you will be getting another driver program. So this driver program is the one which will be act as a main source or point of contact for the complete job execution. So in this driver program, now it tries to start your execution plan. So this driver program will communicate with another person or as a main thing. We call it as a cluster manager. So cluster manager is a service that runs within your Spark itself. So Spark itself has a cluster manager. So what is this? What is the main job of this cluster manager is? So driver program will communicate with cluster manager. So because driver program want to run the job, whatever you have submitted, and to run this job, so the driver program has to connect with cluster manager and cluster manager. So it's a request. So driver program will send a request to cluster manager asking for resource. When we say resource, CPU resource, and then RAM and all those stuff. So for a particular given program, how much memory I have to allocate or how much cores I have to allocate. So these things and all, as a developer, you have to say, you have to specify when you submit your Spark submit command. So how to determine that? There is a special calculations are there. In my upcoming videos, you will be seeing that. As of now, just imagine I'm requesting for 4 GB RAM and some CPU cores. So this request from the driver program goes to cluster manager, and it's request to cluster manager asking for I need this much RAM, this much core. And what this cluster manager will do, this cluster manager will allocate that resource, the particular resource, whatever requested by the driver program. So what this cluster manager will do, so we have slave nodes. Slave nodes in Spark is called worker nodes. So worker node 1, worker node 2, worker node 3, and then worker node 4. So this cluster manager will launch something called executor. So driver program is asking for the resource to the cluster manager. Now cluster manager is allocating the resource in the form of executors. So imagine I'm running this jar file to an input file of size 1 GB, and this 1 GB data has been already distributed in my hard disk. Okay, so just imagine like this 1 GB has been splitted into two. So distributed, so data has to be get distributed before you start your parallel processing. That is the agenda, right? I want to do a parallel processing, and that means your data has to be get distributed before. So now in my I'm using some storage system in which data has been already distributed. Now on top of it, I'm submitting some Spark job. I'm assigning some task. So here imagine this 1 GB file has been splitted as two, so we can call it as blocks B0, B1. So B0 has been stored in, so we can have a number for the nodes. Okay, it's already there. So W3, which is worker node third mission, I have B0, and then B1 is in fourth mission. Okay, so this cluster manager will identify this B0 and B1, and that is we call it as data locality. So I want to start my job only on which my data is present, only on the node in which my data is present. That is called data locality. Imagine now cluster manager is trying to assign a task here, and what is the need? In this node, I don't have any of my data, right? So it's waste. So data locality is something. And I have to understand in which node the particular requested data has been stored. Only in that I have to assign the task. So all these informations will be there with the cluster manager. Now this cluster manager will assign the whatever it is assigning is nothing but it's like a resource. It's creating a resource. Okay, it's not assigning the job what you have written in jar file. So cluster manager will not do that. So cluster manager is just allocating the resource whatever requested by the driver program in this node. So this cluster manager is allocating a resource in the name of executors. Executors, just imagine executor is a box in which your task will get executed. Okay, just imagine like that. So now this executor, once it got created, this executor themselves, they will registered with the driver program. They will send an heartbeat to the driver program once it is created. Also cluster manager will inform I have created the requested resource in the form of executors. So cluster manager will inform at the same time this particular worker nodes, they will send the heartbeat to this driver program saying that this executor has been created. Now this driver program will start monitoring this worker nodes and the executors, and also this driver program will assign the job whatever you have written in this jar file to this executor for the computation. See, I have a job. I have to fetch top one from this B0, and then I have to fetch top one from B1. So my agenda is to fetch top from top first from this file, but this file has been splitted into two. So first I have to fetch top first from this, and then I have to fetch top first from this, and finally I have to fetch top first from these two output. Okay, so now first I have to do a parallelism and then finally I have to do a grouping. Now imagine I'm having 1 GB data which has been splitted as two, and the job what I have written is to fetch top one. So the same job will execute on these two nodes. This executors will launch a task, and this task will take this B0 as an input, and then it will start doing the processing. And this executor again, it will launch a task, and then it will start taking this B1 from the disk, and it will start doing the processing. Okay, so these two tasks runs at the same time. At the same time, this empty worker nodes will also send heartbeats stating that we are live. So that will happen. So it's not only the node which has the job and data will send the heartbeat. It's not like all the worker node will send. So this particular heartbeat that is going to driver program. So these particular heartbeats from the other worker nodes are going to Spark master. Okay, so this driver program is responsible for these two nodes because the data present on these two, and this driver program is monitoring and also assigning the tasks. The task is nothing but the program what you have written. Okay, now these two executor runs at the same time, and then it is also doing the monitoring thing. Now what this executor will do, as I already told you, this executor will launch a task, and once the task is completed, the output of the task will be get stored by this executor. So where this output will be get stored, you can ask me this question. So Spark will store the output in it, that is what we call it as persist in Spark. So persist is a separate topic. I will explain you in upcoming videos, but here just I'm going to give you some one-liner definition of what it is. So we have a persist like disk. What intermediate data? So this is not the final output, right? We call this as an intermediate data. So this is intermediate data, right? Final output is the final top first. Okay, so this is intermediate data. So the intermediate data can be stored in it can be persisted in three ways: disk only, memory only, and then both disk and memory. Okay, so memory only is most efficient because the Spark is all about in memory. So disk is something we will have disk IO. So memory is it's the best one. So imagine like you have a problem with memory, so that you can go with the disk. Okay, this is how the traditional map reduce will work. So your intermediate output will get stored in disk. So here you have both options, and final option is disk and memory. So what is the need of disk and memory is, so for example, the output has been stored in memory, and this output will be get transferred to the next transformation is to fetch the grouping part. I have to group it and get final one. So that will be acted as a separate task, will run in a different machine. So while I'm transferring this data for the next action for next task, so during that time, if the memory has been crashed or something, the intermediate data will get lost. So if I use both disk and memory, so even if the memory got crashed, the data can be get retrieved from the disk. It's up to you, your cluster, based on your cluster resource, based on your design, you can decide which persist mode that you can go with. Okay, so here what is the next step is, so this output will be get stored based on what persist method you have given. So once these two tasks got completed, so driver program will come to know this is completed. So next what is there? Okay, next thing is I have a grouping part in my code. So the grouping can be like reduce by key or sort by key, some a grouping action, sorry, grouping transformations you have written, some shuffle transformation you have written. So now the driver program will decide to go with some other machine which is free to run the shuffle task. Okay, let me pick this. I mean, driver program can pick this. The driver program can also pick these two node also. It's until and unless when the node is free, it will use it. So imagine just driver program is using this node, and executor will be get started here. Again, the driver program will communicate with the cluster manager, and it will get the resource to start the executor here, and this executor will send heartbeat to this driver program, and this driver program will start monitoring this executor. Now this executor will start the task, and this task will read the data, that means this intermediate data, the shuffled data. So when it comes here, the shuffle operation will happen, and then the final output. So this task is something, again, the code what you have written for grouping. Okay, so that code will be get transferred here. This executor will run the task, and then finally the executor will decide where to store the final output. So that can be in disk, or it can be again in memory. So that can be used by the next program for the computation or whatever it is. So finally I can store this in HDFS, or I can store it in some RDBMS, or I can store it in some NoSQL database. That is up to you. Okay, so now whatever we have seen so far is a successful case, right? So driver program to executor. So once the parallelism is completed, final grouping tasks, so all these stuffs we have discussed. And the technical terms, master, worker, driver program, persist methods, and then tasks, executors, everything we have seen, and heartbeats, monitoring thing, client mode, all those things we have seen. Now we can jump into the failure scenarios, which is very important to consider. Now imagine, so here if you see I'm having an executor which is running a task. What if this executor get failed due to some problem, some temporary memory issue or network issue? So if this particular executor only got failed, so the the driver program will retry to create one more executor on this node, and then the task will be get recomputed. So due to this one executor fails, it will not affect any other executor for the same job which is running in another nodes, in other nodes. Okay, so only this particular executor fail, it will relaunch it. Now the next point, what happened if the whole the node itself goes down, the machine itself got crashed, the hardware itself got crashed? Okay, that was one good kind of question that should rise in your mind. So when this particular worker node itself is got failed, so the data what you have in this will be get failed, and the task what was getting executed in this will be get failed. And because of one particular task got failed, you will not get this intermediate output from this node. So without this output you cannot complete your whole job output, right? I cannot miss some piece of output and then finalize the final output, which you can't do. So that means your whole job will be get killed. And again, you have to read the data because this B1 data is missing due to the worker node crash. Again, you have to read the complete data from the source, and then you have to re-trigger the job once again. So how to avoid this scenario? Okay. Now imagine, so I have only one copy of B0 and B1. So if the storage system what you are using in this worker node, imagine if it is HDFS, okay? If you are using file systems like HDFS, which will distribute the data and also which will replicate the data. Am I right? So that means when you have replication, so imagine now I am not using any HDFS file system. The architecture what I wanted to explain you is a standalone Spark. That means you will not have any replication strategy in the disk level. So in that case, what will happen? The replication will not be there for the data, so your whole job will be get killed. But Spark itself has a option to create replication in the memory. You can use RDD to create replications. So imagine your replications are okay. I don't want to confuse you by including HDFS now. So imagine this B0 and B1 can be reconstructed in the memory itself. So because in Spark standalone architecture means you are reading the data from Linux file system or Windows, which is standalone file system, which is not distributed. So when there is no distributed file system where the data comes from is not a distributed file system, then Spark itself has the talent to distribute and create replica for your input data in the memory itself. Okay, Spark has the talent. So now imagine when this data has been getting replicated, so b0 b1, and I have one more copy b0 b1 in this node also, but these all these blocks are in memory. Imagine in that way. Now this particular node itself got crashed, so I have one more copy. So all these informations will be maintained as a metadata information for the driver program, and this driver program will get all this information based on the heartbeat that it receives from the worker node. So when I say driver program, combination of Spark master and driver program, it can able to understand which node has what data, all these metadata informations. Okay, so you can ask me like the metadata information is really held by the driver program and Spark master. Yes, because this is standalone architecture, this is not yarn. Okay, so now this driver program will recreate this executor by discussing with this cluster manager for getting the resource, and this driver program, this cluster manager will launch the executor in this node because the second replica of b1 is here. So the executor will be get created here and the task will be get created here. Only this particular task will be get recomputed, and then it will use b1 and it will give the output. So other tasks will not be get impacted. So as a developer, I will not come to know this is all happening internally. That means some node nodes got down and the executor has been relaunched in some other node. So this as a developer I will not come to know. Okay, so that is a important thing. Failures with respect to the hardware as well as software failures, both the failures we discussed with the executor, means with the worker node perspective, nothing happens bad. Even if get fails, when the replication is available, your job will not be get impacted. So the impact, serious condition is only when there is no replication, your entire job will be get failed, and again you have to read the data from input source, and then again you have to load it, distribute it, and then again you have to rerun the job. Now the condition is, now the next failure case is, what if this driver program got failed? Okay. So when you submit Spark submit command in the standalone mode, you have to specify an parameter called supervise. When you do this, when you pass this supervised parameter, when driver program get failed, Spark master will recreate a driver program, and then all your jobs tasks will be get started from first. Okay, so this driver program once get failed, what will happen is all your worker node executors with respect to that job will get failed. Now when you give supervise, the Spark master will recreate the same driver program for you, and then again it will start recomputing all the program, the tasks, whatever created, whatever required for this particular job. So this is also fine. Now the next question is, what if my Spark master itself goes down? Okay, that is called a single point of failure. So even the problem was there in Hadoop, even I mean in the earlier release version, and even in Spark also in the earlier release we got the problem of SPOC, which is called single point of communication and single point of failure, SPOF. So when you have SPOC, you will have SPOF, single point of failure. So we have a technology called Zookeeper, which helps us to bring HA. HA means high availability. Client used to ask this question, whether this cluster has HA. That means high availability. Even if master goes down, still the running jobs will has to run good. So that is what HA, high availability. So in the Spark and Hadoop initial version, there is no HA. And later point of time, with the help of this Zookeeper, they have introduced more than one master. So that means you can have like one active master and more than one passive master. Passive master is masters that will be ready in position. When active master goes down, the passive will become active. At any point of time, only one active is allowed. The remaining all masters will be in the mode of passive. Okay, so that thing will be taken care by this Zookeeper. So I configured like 4 master for my Spark. One will be inactive, remaining will be as passive master. So now Zookeeper is a daemon which will monitor all these master nodes. Once when the active is goes down, the Zookeeper will do an election, and it will consider any one out of this three as active master. And once okay, this will be an active master, so jobs will not be get impacted. Now I'm repairing this node and I am adding it back to master, means it will get the position as passive master. It will not get active because already active is there. Okay, so now here what passive masters will do, active masters, what active master is doing is it's speaking with cluster manager, getting resource, and then allocating tasks to the executors, that is worker nodes, and monitoring it. What passive master will do, right? Passive masters will not allocate anything, but all passive masters will get heartbeats from all the worker nodes. That is the one thing what passive masters will do. So even though passive master is not doing anything, but it will get heartbeats from the workers. Why it is getting heartbeat? When the active master goes down, when the passive become active, it will be in sync. So that's the reason, even though passive master is not doing anything, it will be getting heartbeats from worker nodes. So that means all these worker nodes will send heartbeats to passive masters also. So this is passive master. At the same time, it will send heartbeats to active masters also. So but active master only will speak with cluster manager, getting resource, allocating task, all those things will be done by only active master. Okay, so here we discussed about HA with respect to Spark, so Zookeeper. Now you can ask me, what happen if Zookeeper get fails? Okay, so that is an interesting question people used to ask me when I explain this HA, high availability. If you take any cluster computing, right, there is two major cluster computing, master and slave, peer-to-peer. Master and slave means this architecture. Peer-to-peer means there is no slaves, no master concept. That is peer-to-peer. Each and every node in the cluster will act like a friends. So if this node goes down, no issues, nothing will be goes down. So there is no SPOC, that means there is no single point of communication. So there is no single point of failure. But Zookeeper comes under leader and follower. This is a cluster type. That means so one leader will be there, two follower will be there. When the leader get failed, the immediate next follower will become leader. So this is how Zookeeper works. So that means at any point of time, there is no need of monitoring Zookeeper. So Zookeeper itself work as leader follower. We don't want to worry about what happen if Zookeeper get fails. So how installing one Zookeeper is a bad idea. So you have to install more than 3+ Zookeepers. Then only your Zookeeper will be in HA. Okay. So but handling HA for Zookeeper it itself will take care. Okay. So in this video, like we discussed most, like the main agenda is when I submit a job, what happens internally, and the failure and success case we have discussed. So this is completely called Spark standalone cluster architecture. I'll be explaining you Spark with Yarn as well. So you will not see much big difference. Okay, with yarn, but spark with yarn is what really people are using in real time. But still, from the spark perspective, standalone architecture, how it works is also important for us to understand. That's why I made this video. In next video we'll see spark with yarn architecture. And thanks for watching a2znowledge.com. If you really like this video, please do subscribe my channel and forward this to your friends and colleagues. I have given my LinkedIn and Instagram URL in the description box. Please do follow us, and we do tech videos in two languages, English and Tamil. And thanks for watching a2znowledge.com.